Welcome to linear programming. These problems are application problems that allow us to maximize or minimize something. So they're maximization problems or minimization problems, if you will. So we're going to go through some examples, or today we're just going to go through the fundraising problem. We're going to talk about different variables. We're going to talk about an objective function. What is our goal? We're going to talk about some limitations or constraints we have that will allow us to find our maximum or minimum, whatever we're trying to find. So let's dive right in. Your class, this is the fundraising problem. Your class plans to raise money by selling t-shirts and caps. The plan is to buy t-shirts for $8, but sell them for $12. So we buy for $8, we sell for $12. And to buy caps for $4 and sell them for $7. The planning committee estimates that you will not sell more than 120 items. Your class can afford to spend as much as $800 to buy the articles. All right, so the first part says your club wants to maximize profit. Okay, maximize profit. Write the profit function P in terms of C and T. So we call this our objective function. Okay, what is our goal? Our goal is to maximize the profit. All right, so this right here is going to be our objective function, but let's talk about how we got that. First, what are we talking about here? Okay, what are the variables? Sometimes it's not always easy to figure out what your variables might be, so we can always go down to the very end. All right, and sometimes that's where our question actually lies. Our ultimate goal is to tell how many t-shirts and caps your class must sell in order to maximize profit. So that helps us define our variables. Our goal is to talk about t-shirts and caps. So step one is we define those variables, T and C, okay, because they told us to write it in terms of those. And now we need to talk about our profit function, okay? So how did I get P equals 4T plus 3C? Well, let's go back up to our information. We buy t-shirts for $8, but we sell them for $12. So how much money are we making off of each t-shirt? $4. So that's where that 4T comes from. Our caps, we buy caps for $4, but we sell them for $7. So how much are we making on each cap? We make $3 on each cap. So our objective function that is talking about profit, because our objective is to maximize the profit, is going to be 4T plus 3C. Now we hold off on this until the very end, okay? Now we need to talk about some constraints, and these constraints are inequalities. And when we're trying to determine what our inequalities are, we go back to our information and we look for key phrases that represent inequalities. So in this case, I see the phrase, will not sell more than. So that piece right there, not sell more than 120 items. Okay, well, our items are t-shirts and caps. So since it's not sell more than, I know that that's going to be less than or equal to. Okay, so not sell more than, less than or equal to. So when we write our inequality, we have our items, t-shirts plus caps has to be less than or equal to 120. Okay, then I also see your class can afford to spend as much as $800 to buy articles. Okay, so I see as much as, and again, I'm thinking less than or equal to. But it's talking about cost. Okay, so we need to talk about, well, how much do we spend on each t-shirt? Well, at the beginning it told us we can buy them for $8. So that's where I got 8T from. And the caps we buy for $4. So plus 4C. And we can't spend more than, or we can spend as much as $800. So that's where a less than or equal to 800 comes from. Now, where does this T and C greater than or equal to 0? Well, I call these our gimmies. These are our have-tos, okay? We can't sell negative amounts of t-shirts and we can't sell negative amounts of caps. So these are our gimmies, but they're also considered, I suppose, our invisibles, okay? They're not talked about. These we just have to think about in terms of the problem themselves. So you have to make sure you include those. Okay, so now what we're going to do is we're going to graph these constraints, because these constraints help us to find a maximum or minimum profit. In this case, we want to maximize it. So now we're getting ready to graph. So the first thing we have to do is, one, we label our axes. So I let t-shirts be the x-axis and caps be the y-axis. Okay. Now, actually, before we go to graphing, I need to talk about what ordered pairs we're going to be graphing for each of these. So if we're graphing t plus c is less than or equal to 120, I have my table. When t is 0, we're going to plot 120, and when c is 0, we get 120 as well, so those intercepts. Figuring out the intercepts for our green, when t is 0, we get c to be 200, and when c is 0, we get t to be 100. So I'm going to use this to help figure out what I should scale it by. And what we should notice is that there are 24 tick marks total. So this is a 24 by 24 grid. So how do I scale this? I want to make sure I'm utilizing my entire scale. So I do a little side note over here. Okay, my t's, the highest I go for t's is 120. So I'm going to take 120, I'm going to divide it by the 24 squares that there are, and it comes out to be an even 5. So I know each tick mark on my t's is going to go up by 5s. My c's, the highest c value I go to is 200. So 200 divided by 24 is about 8.3, but that's not a nice scale to use. So I just round up to a nice even 10. So my c's will go up each time by 10. So that's how I was able to figure out my scale, and it's okay that they're not the same. So now we're going to go ahead and we're going to graph these inequalities. So when we plot t plus c is less than or equal to 120, I'm going to plot those 2 points, 0, 120, and 120, 0. So 0, 120, and 120, 0, and we go ahead and we draw our line there. Now to figure out where we're going to shade, you can choose the point 0, 0, and it turns out to be true, so I would be shading below that pink or that purple line. To graph my green inequality, again, we're going to use that table. So 0, 200, and 100, 0. Go ahead and draw that line in. But we have to remember we have to shade for this guy too. And testing the point 0, 0 would mean we're shading below that line as well. Okay. Don't forget to graph your invisibles. All right. When t is greater than or equal to 0, we're going to be shading to the right. And when c is greater than or equal to 0, that horizontal line, we're going to be shading above. Okay, so now we have where our shading is. We can go ahead and shade up our region in here, this yellow, and what this is called our feasible region. Okay, our feasible region. Now, this is where the amounts of t-shirts and caps can be sold, anything within this. But we want to figure out where we can maximize our profit. Maximizing or minimizing only occurs on the vertices of our feasible region. So we need to label these. Okay, so I labeled, or I just put a point in red where the vertices of our feasible region is, or corners, you can think of it. Okay, now some are very easily identifiable. I know that this point is 0, 120, so we label it. This is 0, 0, label it. This point over here is 100, 0, we label it. We don't technically know this yet. Okay, so we have to prove what this vertex is, what this corner is. So I know that this is the intersection of my green and my purple inequalities. So I'm going to focus on those and figure out the intersection there between the purple and the green. Now I make them equations because I want to know where those lines intersect. So we solve this system of equations. I multiplied the purple by -4 and I eliminated my c's. So I got 4t equals 320, which gave me t to be 80, and when I plugged that back into my top, I got c to be 40. So now I know that that intersection is for sure 80, 40, and we go ahead and we label it. But now, to figure out how many t-shirts and caps we need to sell in order to maximize our profit, we're going to go and create this table of values, and now we're going to go back to that first part and use our profit function or our objective function. And we're going to plug in the vertices, okay, so these are our vertices, into our objective function, our P function. So our four corners, 0, 0, 0, 120, 80, 40, 100, 0. We plug that into our objective function, our profit function, and we get these values here. And what we want to look for is the highest profit, the maximum profit. And that occurs here when we sell 80 t-shirts and 40 caps. We will maximize our profit. So the very last thing we have to do is just interpret our table, okay? So our class must sell 80 t-shirts and 40 caps to maximize profit of $440, okay? So you want to make sure that you're showing all of your work. You need to make sure that you prove any intersections that aren't easily identifiable, meaning any of those intercepts, those are easy. But anything where two of the inequalities meet on those lines, you need to set up a system and show that algebraically. Okay? To figure out your maximizing or minimizing portion, you need to show you were plugging in your vertices into your objective function. Okay? And then highlight either the maximum or the minimum. And then we state our final answer. So if you have questions, this was just more as a reference, but if you have questions, by all means, make sure you ask your teacher in class next time you see them.